Hey everyone, ready for a deep dive into something pretty cool.
I am.
It's all about controllable video generation. We're looking at this research paper. It's called
Oh, cool.
AnimateAnything, Consistent and Controllable Animation for Video Generation.
Catchy title.
It is. It's by Li Wang, Zhang Wang, and Xu.
Hey.
Sounds kind of complex, but trust me, it's going to be fun.
Looking forward to it.
So what's really cool about AnimateAnything is that it can work with all sorts of different control signals.
Like what?
Think about it. You could be manipulating video using
No.
just camera movements, text prompts, or even sketching something on a still image.
Really?
Yeah.
Wow.
So you could basically bring a static image to life in a ton of different ways. If you look at figure 1 in the paper, they actually show you how a single image, in this case it's a horse on a hillside, can be animated differently using these various control signals.
Interesting.
You could sketch an arrow to make it gallop or define a camera path if you want a sweeping panoramic shot.
So it's tackling a big challenge in video generation then, creating those realistic and especially large-scale movements.
Right, and the paper highlights how existing solutions kind of fall short in this area.
Yeah.
For example, methods like motion credle and camera credle, they rely a lot on text descriptions, which, text can be great, but it can lack the precision you need for more nuanced motion.
Makes sense.
And then you've got image-based methods like Motion I2V and MOFA Video. They offer, finer control, but they often struggle with complex camera movements.
Yeah, or they require a ton of user input, which can be a pain.
Exactly. So AnimateAnything, it takes a totally different approach. It uses this clever two-stage process. First, it kind of acts like a universal translator. It converts those diverse control signals into a shared language, and that language is known as optical flow.
Optical flow.
Yeah, so it's almost like translating camera trajectories, text prompts, and annotations into a language that the system actually understands.
Okay, I think I'm starting to get it.
So optical flow, it basically maps how pixels are expected to move between frames. It's like the motion blueprint of the video, So AnimateAnything's first stage, it's all about generating this unified optical flow from any given control signal.
So it's figuring out the motion no matter what kind of instructions you give it.
Exactly.
That's pretty clever.
So to break down this universal translator a little further, the paper refers to it as the multi-scale control feature fusion network.
Multi-scale control feature fusion network. A mouthful.
Yeah, a bit of a mouthful. But basically what it does, it analyzes the control signals. It figures out what kind of motion you want, and then translates that into a corresponding optical flow pattern.
So it's not just blindly following instructions, it's actually understanding the intent behind them.
Right, exactly. And this network, it's super flexible. Let's say the control signal is camera movement. AnimateAnything will create that smooth, sweeping optical flow that you'd expect for a panning shot. But if you just, draw a little arrow on a still image, that will result in a more localized optical flow around the area where you want movement.
So different instructions, different types of flow.
Exactly. Figure 2 in the paper actually shows this visually. You can see how different control signals lead to these unique optical flow patterns.
I'll have to check that out.
Yeah, it's pretty cool.
So it's almost like AnimateAnything can actually grasp the intention behind your actions.
Right. It's not just understanding the intent, though. It also has to manage potentially conflicting instructions.
Oh, yeah, I didn't think about that.
Imagine you combine a camera pan with a user-drawn arrow. You want the camera to move, but also a specific object to move in a certain way.
Those signals could clash and create a confusing optical flow.
Exactly. That's where the explicit and implicit injection modules come into play. They act like specialized handlers for those different types of control signals.
Okay.
So explicit injection, that manages signals like arrow annotations. It directly converts those into movement instruction.
Yeah.
While implicit injection handles the more complex signals, like camera paths, it smoothly integrates them into the overall optical flow.
So they work together to prevent any conflicts.
Exactly. And then all this information, it gets fed into the flow generation model, or FGM for short.
FGM.
Yeah, this model takes the initial sparse optical flow that's derived from your input, and it refines it into a dense, detailed flow that's going to guide the animation.
So it takes your rough sketch and turns it into a precise plan.
Exactly. And to make sure the animations are smooth, no flickering, AnimateAnything, incorporates a frequency stabilization module.
Frequency stabilization module.
Yeah, this module analyzes the video in the frequency domain. It smooths out any jarring jumps in motion, so you get a more polished result.
Ah, that makes sense.
So now we have this unified, refined, and stabilized optical flow. It's ready to direct the actual video generation.
Hmm.
This all happens in stage 2, right?
That's right. Stage 2 uses that optical flow to generate the final video frames, making sure the motion perfectly aligns with your control signals. They actually build upon the CogVideoX framework for this, but with a clever twist.
Oh.
They introduce a flow encoder to compress the optical flow information and a vision transformer block to integrate it with the video's latent representations. It's like weaving the motion blueprint into the very essence of the video itself.
Wow, so it's not just about motion then. It's about creating a cohesive visual narrative
Yeah,
that reflects all the control signals you've chosen.
exactly.
It's like conducting an orchestra of video elements.
A very accurate analogy, and the results, as highlighted in the paper, are quite impressive.
Let's dive into those results then. Let's start with camera trajectory control. The paper compares AnimateAnything to existing methods, like camera crawl and motion cradle, and the difference is pretty clear.
Oh, yeah.
AnimateAnything consistently and accurately follows those intricate camera paths. Table 1 actually shows this. It shows much lower translation and rotation errors compared to the other methods.
So smoother and more realistic camera movements in the generated videos.
Exactly.
And it's not limited to just camera movement, right? AnimateAnything also excels at converting user annotations into those convincing animations.
But remember how MOFA video could be a bit cumbersome with those pixel movement specifications?
Yeah, it was a lot of work.
AnimateAnything simplifies that whole process. You can just sketch simple arrows on a still image to indicate the motion you want.
Like, just draw an arrow where you want something to move.
Exactly.
And it figures it out.
Yeah, and it generates the corresponding animation with remarkable accuracy. If you look at Figure 7, they have these side-by-side comparisons. And you can really see how AnimateAnything is superior in terms of smoothness and consistency.
That's impressive.
And then for the final impressive feat, AnimateAnything can even transfer motion from reference videos.
Really?
Yeah, it analyzes the movement in one video and applies it to a different scene,
Hmm.
creating these compelling animations with remarkable style consistency.
So you could take, like, a dance move from one video and apply it to a character in a completely different setting.
Exactly.
Wow.
You can see this in Figure 6. They actually show the original video next to the generated animation. It's amazing how well AnimateAnything captures the nuances of the reference motion.
It's like motion capture, but for video generation.
Right, it unlocks a whole new world of creative possibilities.
And all of this is thanks to that innovative two-stage approach and AnimateAnything's sophisticated handling of those diverse control signals.
Yeah, it's a significant breakthrough in controllable video generation.
Definitely.
The paper also goes into detail about how they trained and tested AnimateAnything. They use a combination of large-scale datasets, like Real 10K, WebVid 10M, and OpenVid.
That's a lot of data.
It is, and they even address the challenge of training for camera trajectory control, where data is often limited. They cleverly used a subset of videos from OpenVid with fixed camera positions to start their training.
Oh, that's smart.
Yeah, it just shows how resourceful they were. They also discussed some of the technical challenges and solutions, like how to handle potential noise in the optical flow data.
Right, because real-world data is never perfect.
Exactly.
Which brings us to the ablation study. This is where they systematically tested different components of their system to prove how effective they are.
Right, so they basically took things apart and put them back together to see what really mattered.
Exactly.
Table 4 breaks this down really well. It shows how each component contributes to the overall performance.
So they proved that their design choices were the right ones.
Exactly. It confirms that the two-stage pipeline, the frequency stabilization module, and even those noise handling techniques, they're all essential for getting those impressive results.
It really highlights the meticulous design and testing that went into AnimateAnything.
So to sum it up, AnimateAnything isn't just another small step forward in video generation. It's a paradigm shift. It offers these unprecedented levels of control and flexibility.
Definitely a game changer. And with that, we conclude part 1 of our exploration of AnimateAnything. We encourage you to dive deeper into the paper yourselves and let your imagination run wild with the possibilities.
We'll be back soon with part 2, where we'll explore some of the technical intricacies and challenges of actually implementing AnimateAnything.
Until then, keep those creative sparks flying. Welcome back.
Okay, so
In the previous part of our deep dive, we uncovered the remarkable capabilities of AnimateAnything. This system that's really revolutionizing controllable video generation.
It is pretty amazing.
We witnessed its ability to translate all sorts of different control signals like camera movements, text prompts, even those hand-drawn annotations
Yeah.
into a unified language of motion, which we call optical flow.
Yeah, it's like having that universal remote for video. We can manipulate scenes in ways that we just couldn't before.
Exactly. We explored how AnimateAnything generates these smooth, realistic animations, how it accurately follows these complex camera paths, and even how it can transfer motion from reference videos.
Right.
Really impressive stuff. But like any groundbreaking technology, the true brilliance, it lies in those technical details.
And that's what we're going to be unpacking in this part of our deep dive. The intricate technical workings that make AnimateAnything tick.
Right, and the researchers were actually very transparent in the paper about the challenges they encountered while developing this system.
Okay, so what were some of those challenges?
Well, one of the primary hurdles they discuss, it's in section 3.4, training details, is the scarcity of data for training models, particularly for camera trajectory control.
Right, because to train a model to accurately follow a camera path, you need a huge data set of videos with that precise camera pose information.
Exactly, and this type of data, it's not readily available,
Okay.
especially for dynamic real-world scenes.
Yeah, the existing data sets, like Real 10K and DL3D V10K, they primarily consist of indoor or static scenes.
Right, which aren't really suitable for training a model that needs to handle the complexities of camera movement in more dynamic environments.
So how did they get around this problem?
Well, they employed a pretty clever strategy. They identified a subset of videos from the OpenVid data set that were captured from, relatively fixed camera positions.
So they were able to leverage those videos.
Exactly. They assumed a fixed camera pose as the initial condition.
Okay,
So they essentially bootstrapped their training process.
interesting.
They first trained the model on Real 10K, and then they fine-tuned it on these carefully selected OpenVid videos with those fixed camera viewpoints.
So they were able to utilize those existing data sets while still incorporating some element of dynamic camera movement.
Exactly. And to further enhance the model's robustness, they introduced noise into the optical flow data during training.
Wait, introducing noise, wouldn't that make it less accurate?
Not necessarily. Think of it like adding a bit of turbulence. During a flight simulation,
Okay.
it forces the model to adapt and learn to handle those imperfections in the input, making it more resilient to real-world conditions.
So it's like preparing the model for the unexpected.
Precisely. And they actually found that this noise injection significantly improved the performance of their video generation model.
That's pretty counterintuitive, but it seems to have worked.
It did. It really highlights their meticulous approach to training and optimization.
So are there any other challenges they had to overcome?
Yeah, another interesting detail they emphasize, it's in section 3.3 framework, is the importance of managing potential conflicts between those different control signals.
Right, we talked about this a bit earlier, the explicit and implicit injection modules.
Exactly. Those modules are crucial for ensuring the coherence of the optical flow generated from those multiple control signals.
So for example, let's say the camera pans across a scene, but at the same time, a character is moving independently.
Right, those two motion vectors could potentially clash, resulting in jerky or unrealistic animations.
And the injection modules prevent that.
Exactly. They act as these intelligent mediators,
Yeah,
smoothing out those conflicts and ensuring a seamless blend of motions.
that's pretty clever.
They achieve this by carefully considering the nature of each control signal and its influence on the overall optical flow.
So like a user-drawn arrow, that might only affect a localized region of the optical flow, but a camera path would have a more global impact.
Exactly. The injection modules take these nuances into account, ensuring that each control signal contributes harmoniously to the final animation.
It's like conducting an orchestra, making sure each instrument plays its part.
An apt analogy indeed. This careful orchestration of control signals is what allows AnimateAnything to generate those remarkably consistent and controllable animations.
Really impressive stuff.
And beyond these, practical considerations, the paper also delves into some of the theoretical underpinnings of their approach.
Oh, interesting.
One key concept they highlight is the use of frequency domain analysis in their frequency stabilization module.
Right, the module that smooths out those jarring jumps in motion that can cause flickering.
Exactly, and it's discussed in section 3.3.4, frequency stabilization module. So instead of analyzing the video frame by frame, this module examines the overall patterns of change over time.
It's like analyzing the rhythm of a song. rather than focusing on each individual note.
Precisely. By examining the frequency spectrum of the video, the module can identify and smooth out those jarring transitions that cause flickering without sacrificing the essential motion information.
So it's a subtle but powerful technique.
It is. It greatly enhances the visual quality of the generated animations.
It shows how much thought they put into every aspect of the system.
It demonstrates the researchers' deep understanding of both the artistic and technical aspects of video generation.
Yeah, they're not just computer scientists.
They seamlessly blend principles from signal processing, computer vision, and animation to create this robust and versatile system.
So it's a truly interdisciplinary approach.
It is, and that's what really sets AnimateAnything apart.
Okay, so we've explored the training process, the handling of those conflicting signals, and the use of frequency domain analysis. Now let's get to the heart of the system, the generation of those stunning video frames.
Right, this is where the magic of diffusion models comes into play.
Diffusion models.
Yeah, they've revolutionized the fields of image and video generation. And AnimateAnything leverages their power to create those lifelike animations.
Okay.
But they don't just use them off the shelf, They've adapted them to incorporate those unified optical flow representations we talked about earlier.
So they're not just using existing technology.
They're innovating on top of it.
Interesting.
They essentially weave the motion blueprint derived from those control signals into the very fabric of the video generation process.
It's like giving the diffusion model a choreographer, guiding its every move to match your creative vision.
Exactly. And this is where their modifications to the CogVideoX framework come in. It's detailed in section 3.3.3, video generation. They introduce a flow encoder to compress the optical flow information and a vision transformer block to integrate that information with the video's latent representations.
So it's a lot of complex processing going on behind the scenes.
It is, but it ensures that those motion cues are seamlessly embedded into the generated frames.
And that results in the smooth, consistent, and controllable animations.
Exactly. It's a testament to the power of combining those cutting-edge techniques with a deep understanding of the underlying principles of video generation.
So they're not just throwing technology at the problem.
They're really thinking deeply about how it all works together.
This attention to detail, both in the technical implementation and the theoretical foundations, is what makes AnimateAnything such a remarkable achievement.
It's a true game changer, pushing the boundaries of what's possible in controllable video generation.
Welcome back to our deep dive into AnimateAnything.
Part 3 already?
We've covered a lot.
We have.
Explored its capabilities, delved into the technical details. It's a real game changer. We've seen how it takes all those different control signals, turns them into a language of motion, uses that to generate those realistic, controllable animations.
Right, from camera movements to user annotations, even transferring motion from other videos.
AnimateAnything seems to do it all.
It does a lot.
But one question that's still kind of lingering for me. What does all this mean for the future of video creation?
That's the big question. And the researchers actually touch on this in Section 4, Experiments.
Oh, cool.
They highlight how well AnimateAnything performs across all these different tasks. You can see this in the quantitative results in Table 1 and Table 2.
Okay.
For example, with camera trajectory control. AnimateAnything consistently outperforms other methods, like camera crotch roll and motion control.
And how do they measure that?
Well, they look at the translation and rotation errors. AnimateAnything has much lower errors, meaning it's more accurate at following those camera paths.
So it's more precise.
Exactly.
And what about user annotation control?
It excels there too. Figure 7 shows how well it translates those simple arrow annotations into smooth animations.
I remember that figure. The comparisons were pretty striking.
They were. AnimateAnything is clearly superior to Mofa Video and DragAnything in that domain.
And don't forget about motion transfer from reference videos.
Right. Figure 6 illustrates that.
The style consistency is just remarkable.
It opens up so many possibilities for video editing.
It really does.
All of these results, they demonstrate the effectiveness of AnimateAnything's approach. The two-stage process, the frequency stabilization module, the way it handles all those different control signals.
Yeah, it all comes together really well.
But beyond the numbers, what's really exciting is the potential impact.
On different industries, different applications.
Exactly. Think about filmmakers. Seamlessly integrating CGI characters into live-action footage.
Just with a few annotations.
Right, or game developers creating these massive, immersive worlds with characters that move realistically.
It could revolutionize so many things.
Absolutely, and it goes beyond entertainment, too. Think about education, scientific visualization.
Oh yeah, students could learn complex concepts through animation.
that make it more engaging, more intuitive.
And scientists could visualize data in new ways.
Exactly, ways that are both informative and visually compelling.
The possibilities really are endless.
They are.
As the technology keeps evolving, who knows what incredible creations will emerge?
AnimateAnything has definitely pushed the boundaries, setting a new standard for controllable video generation.
It's amazing what can be achieved
Yeah,
when you combine creativity with cutting-edge technology.
it really is. It's been fascinating exploring this research with you.
Likewise, I feel like we've only scratched the surface.
We probably have. There's so much more to uncover. But for now, we'll have to wrap things up.
Right. But thanks for joining us on this deep dive into Animate Anything.
And until next time, keep those creative sparks flying.